Okay, everybody, this is our last lesson in the chapter, lesson 2.9, where we are going to prove lines to be parallel. Yes, we will be doing two very easy proofs at the end of this lesson. And I would like you to write this down. Again, please pause this video at any time and copy the notes down. And obviously, after you copy them down, you need to take a picture of it, send it to your teacher. These are the theorems to prove lines are parallel, and pretty much this is actually what you would write in the reason column of a proof. If two lines are cut by a transversal so that the blank are congruent, then the lines are parallel. And we know from yesterday that the ones that are allowed to be congruent are the corresponding angles. So if the corresponding angles are congruent, we got parallel lines. What are the other ones that are congruent? Remember the alternate interior angles? If they're congruent, lines are parallel. And there's a third one, alternate exterior angles. If they're congruent, any three of these, if I start off with saying, hey, these two angles are congruent and those two happen to be alternate interiors, then lines we know are parallel. Then what's that other one that we learned about yesterday? Remember, it was the consecutive interior ones. The consecutive interiors aren't congruent. They're supplementary. So if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So again, just to kind of give you a visual of what this looks like, look at number 1 and number 2 right now. What kind of angles are those? 1 and 2. So if I turn it sideways, those are making that F shape, which are corresponding angles. Then line A and line B are parallel because the corresponding angles are congruent. Let's look at this one, 5 and 6. Those look like they're alternating and they're on like the interior. So these are alternate interior angles that are congruent. Then which lines are parallel? M would be parallel to N. Let's look at these over here, 9 and 10. 9 and 10 look like they're on the outside, they're exterior, so these are alternate exterior angles congruent. Then W and X are parallel. And then 3 and 4 are the ones that make that C shape, that U shape. Those are consecutive interior angles. They're not congruent. They are supplementary. Then these two lines, K and H, would be parallel. And so that's what we're going to talk about mainly today. Let's talk about one more theorem. In a plane, if two lines are perpendicular, to the same line, then the lines are parallel. So here's what this means. This means if I told you that R and P are perpendicular, and I told you that R is perpendicular to Q. Okay, so in a plane, two lines perpendicular to that same line to R, then these two lines, P must be parallel to Q. Okay, and that again goes along with the corresponding angles both being 90 right here. There's that F shape, that backwards F shape. Very easy. All right, so we're going to try this now a different way, something that you'll be doing on homework. This is how homework will be tonight. Okay, they're going to give you the following statement. 7 is congruent to 9, or 8 is congruent to 5, or these two are supplementary. You have to go along here and determine which lines are parallel because of those two, and then tell me the theorem, okay? And your theorems will either be corresponding angles are congruent, lines are parallel, et cetera, et cetera. So let's see, 7 and 9, let's go circle that. Looks like they're alternating across a line, looks like they're on the inside of it. So I would say these are alternating interior angles being congruent. Then which two lines would be parallel? Would it be the Y and Z? No, it'd be, again, this would be the transversal they're alternating across. So where's that transversal cutting? It's cutting the W and the X. So W is parallel to X. All right, let's try another one. 8 and 15. All right, let me find 8 and 15. Okay, so again, looks like they're alternating across this transversal. So they are alternating on the exterior angles being congruent. And which two lines would they be then parallel? Well, again, if this is my transversal that they're alternating, those would be the two parallel lines. Y would be parallel to Z. Let's try another one. 5 and 9 add up to 180. Let's see, 5 and 9, here's 9 and 5, 9 and 5. If they add up to 180, that means they must be consecutive interior angles, and they are supplementary, which means which two lines are they supplementary on the interior? They're this one, these two right here where that C, where it makes the C shape. So Y and Z would be the parallel lines. And then last but not least, 6 and 13. 6 and 13. Let me see if I can get a highlighter here to get this a little better. 6 and 13. Oh, those are those F shape. Here would be the transversal. So theirs would be the F. See that F right there? So they are corresponding angles, which are congruent. And what are the lines that are being parallel to? That would be W and X. Okay, so it can get very complicated when you've got two sets of parallel lines, but you just, again, highlight where the transversal is and then highlight the two lines that are parallel next to it. So you'll have a few of those to do. Then you'll have some questions about just finding X so that the line L and M are parallel, and then obviously identify the theorem along with that. So let's do this one. I've got 5x plus 7 right here on an interior and 7x minus 21 on an interior. So those look like they're alternate interior angles being congruent. And that's what makes L and M parallel. So then I can actually just set them equal to each other. Oops. And then let's do a little solving. Minus 5x would be 2x. Add 21 over would be 28. X is 14. Easy. You don't have to find the angle. You just had to find x. If it said find the angle, we'd have to plug x back in. All right, and alternate interior angles are congruent. All right, let's see about this one. This looks like this one. This is that C shape, consecutive interior. They must add consecutive interior angles are supplementary. So that means 7x minus 2, this angle, plus this angle must equal 180. And so let's solve for x. That would be 4x plus 8 equals 180. And then do minus 8 would be 172. And divide by 4. 43. That's what x equals. So they are consecutive interior to be supplementary. All right, and then this last one, this is 90, this is 5x. This looks like that F shape. I know you want to say, you know, that last theorem I told you about the lines being perpendicular, but we don't know that for sure, but we do know it definitely are, they're corresponding. So corresponding angles are congruent, making the lines parallel. So 5x minus 20 must be congruent to this little box, which is 90 degrees. 5x equals 110. So x is 22. Okay, so you'll have a few of these tonight. You have to state the theorem. Again, it's pretty much just saying again what they were yesterday. Oh, they're corresponding. Oh, they're consecutive interior. Oh, they're alternating interior. And then solve for x. So that should be an easy part of the homework tonight. Of course, we need to do some proofs because we love proofs. They're not hard. These are actually super simple proofs. They're actually quite the same. So again, pause the video if you need to and copy this proof down. We're going to go through it together right now. So given that angle 1 is congruent to angle 2, I'm going to just mark it up. Prove that L and M are parallel. You know, it would be good if I told you that this was L and this was M. All right, so number 1, we know it. Given, if you get one wrong, y'all, you have disappointed me. Number 1, given. All right, number 2, why are 2 and 3 congruent? Why are these 2 congruent? Do you remember what these are called? They're vertical. And we know that vertical angles are congruent. That's literally the reason. All right. So now, why is 1 congruent to 3? Now, be careful. You can't just say right now that 1 is congruent to 3 because their corresponding angles are congruent. We don't know that these lines are parallel. We don't know they're parallel. We're proving they're parallel. But we can go back up here to what we've talked about. Look at your statements. 1 is congruent to 2. 2 is congruent to 3. Then I'm allowed to say 1 is congruent to 3 because of what reason? Remember? 1 to 2, 2 to 3, 1 to 3. Isn't that like a train? Transitive. The transitive property. All right, now that I've got 1 and 3 congruent, now I have them congruent with the transitive property. Now I can finally say that the 2 lines are parallel. Why? Because now they're forming that F, upside down F, but that's what they're forming. So you will say, because the corresponding angles are congruent, the lines are parallel. So see, simple, really easy, simple proof. Not too hard. This would be your last statement whenever you have a parallel. It would be like corresponding angles are congruent or alternate interior angles are congruent, the lines are parallel. That's what you, every time you say that right here. One more quick little proof. Very similar. Very, very, very similar. Just wanted to show it to you in a different way. Again, pause for a moment, copy this down, and we'll go through it. Here is a parallelogram ABCD. And they've labeled some angles inside for us. We are to prove that line AB is parallel to DC. Line AB is parallel to DC. And look at that. They so helped us out here. 1 is congruent to 2, and 1 is congruent to 3. Lovely. All right, so number 1, given. All right, why am I allowed to say that 2 is congruent to 3? Again, go back up here. If 1 is congruent to 2 and 1 is congruent to 3, then 2 is congruent. It's that property again. It's that train. It's that transitive property. Okay, now, if 2 and 3 are congruent, why am I allowed to say that this line and this line are parallel? What kind of angles are those? Looks like they're alternating on an inside So alternate interior angles are congruent, lines are parallel. And that's it, guys. That's how easy it should be tonight. All right.